So 7.3 is adding and subtracting rational expressions and then finding the least common denominator. And the very first little bit here is just talking about adding and subtracting fractions when you have a common denominator already. And that's actually the most user-friendly form of fractions or rational expressions, is if all the denominators are the same, then you just add or subtract straight up across the top, and it makes our life really, really simple. So obviously, if it makes our life really, really simple and we're in a math class, I think you're going to have like 2 or 3 of those, and then we're going to make it more complicated. But no matter if you are given a common denominator or if you are trying to find a common denominator, that is something you have to have when you add or subtract fractions or add or subtract rational expressions. Last time in 7.2, we were multiplying and dividing, and we didn't have to worry about what the denominators were. We usually looked at them anyways because we simplified on the front end, and we wanted to get rid of some things before we multiplied in order to keep things as simple as possible. But here, our main goal is to make sure we have common denominators so that then we can add and subtract across the top. The one thing we do have to be a little bit careful of is when we are doing subtraction, this subtraction applies to anything that is on the top of our second fraction. And sometimes if it's a binomial or a trinomial and things like that, we're going to have to distribute that negative. And I would say that's probably one of the most commonly missed steps that happens. And we will see that happen on our fourth example. And so I'll try and point it out so that you can kind of highlight that and pay really close attention, because dropping a negative is the most common mistake. I do it. It's also one of the most frustrating mistakes, because you get to the end of the problem and you're like, why isn't it correct? And then you go through and you're like, really? I dropped a negative on the second step, and then you have to go change everything. So it is annoying if you drop a negative, but it's also not huge conceptual error, which is a nice thing. If you need more practice with adding and subtracting fractions, or really with anything with basic fractions, my Math 20 video for 1.3 is where we did all of the adding, subtracting, multiplying, and dividing with basic fractions. This very first example would have been an example pretty much straight out of Math 20. And so just if you need extras, there is that video available as well. So A is about as simple as it can get. It's all numerical. There's no variables. There's no expressions. It's just 1 over 8 plus 3 over 8. The denominators are the same. And so what we're going to do is we add straight across the top. 1 plus 3 is 4. The denominators we do not add. They stay whatever the denominator is. And then we ask, does 4 have anything in common with 8? Can it be simplified? And it can. It can simplify down to 1/2. You always want to make sure that you take it out as far as you possibly can before you type in your answer. And you also do not want to give decimals. Don't use your calculator and tell me that it's 0.5. You will get it wrong. B is also simple in the grand scheme of things, because even though we do have binomials on top and bottom of both of our fractions, our denominators are already the same. We don't have to worry about getting a common denominator. X minus 5 is the same for both. And so again, we're going to add straight across the top. My first fraction was an x plus 1. My second fraction is a 2x plus 3. So then I'm just combining like terms. I have an x and a 2x, which gives me a 3x. And I have a 1 plus a 3, which gives me a 4. That green is not going to make it. Now, as these problems get progressively harder, we will need to start checking to make sure that we can't factor and cancel out anything. In this case, 3x plus 4 has nothing in common. X minus 5 has nothing in common. There is nothing for us to factor out. But we just came from our factoring chapter in chapter 6, so it will end up happening to where things will cancel out, and we just need to be aware of that as we progress through these. Are there any questions, though, on these first two? Pretty straightforward, pretty simple. Let's make it a little bit harder. Again, the denominators are already the same for us on C, which is really nice. So we're just going to add straight across the top. So I have 2x squared, and I'm going to kind of cut out this middle step just because I can. So I'm going to write it in descending order. So I have 2x squared, and then I have a plus 6x. And then I would have a 7 minus 7, so my constant term actually goes away, and that's okay. All over an x plus 3. If you don't like skipping this step, feel free to write it. Write it all as one big fraction, and then write your next one in descending order once you've combined all your like terms. You can also kind of cheat with the very beginning problem by just doing this, since it was addition, and kind of ignoring that one. I like to save paper space as much as possible. Now, at this point, you want to be careful, because if you type this in, you're going to be wrong, because this is not fully simplified. If we look at our top terms, we have a 2x squared plus a 6x. What do those have in common? A 2x. And if I pull out a 2x, that leaves me with an x plus 3 inside. And notice what our denominator is. It's an x plus 3. Since I have an x plus 3 on top and an x plus 3 on bottom, those cancel, meaning my final answer is just simply 2x. A lot of stuff canceled, and I have a pretty basic answer at the end. So this is where we're going to utilize all of the information that we had in Chapter 6 as well to factor and make sure nothing else ends up canceling. Questions on that one? That's the first one we've had that kind of does that. All right, let's bump it up another notch. Let's do a subtraction one because we haven't done one yet. We'll do x squared minus 6x plus 3. And you can't really see that. All over x squared plus 7x plus 12 minus Okay, so obviously this one's a little bit more complicated because our numerators and denominators are made up of quadratics. But the nice thing is that we're still in the quote-unquote easy section and that the denominators are the same. We don't have to worry about them at all. We don't have to try and find a common denominator. They're already common. So what we're going to do is we're going to do the subtraction across the top first, and then we're going to see if the top factors and the bottom factors, and if they do, can we cancel out any of those factors? And this is where we have to be careful because before with addition, we didn't have to worry about changing any signs or anything because we were adding. But here with the negative, that negative applies to every term that's on top. You can kind of think of it as writing it like this, where we're going to have to distribute that negative to each of those terms. And so I'm not taking x squared plus x squared, I'm taking x squared minus x squared, which means those are going to cancel out. And then I'm going to take a negative 6x, and then I'm taking this negative times a negative here, so it'll be a positive. It'll be a negative 6x plus 8x, and then I'll have the plus 3, and then a negative times the negative 5 will give me a plus 5. This is what's going to be left on top because my x squareds do cancel out. So if I just look at this, I'm not going to write the bottom just for a second. I'm going to just simplify this. I have a negative 6x plus 8x, which will give me a positive 2x. And then I have a plus 8. And all of that will end up over my denominator, the x squared plus 7x plus 12. Now, before you even try to factor the denominator, you can look at the numerator, the top, and say, okay, does anything factor in here? Because if I have a 2x, I know that's not going to work down here because I only have an x squared out front. So if nothing were to factor out of the top, then I would know I was done already. But does something factor out of 2x and 2x and 8? A 2 does. And if I pull that 2 out, I'm left with an x plus 4 as a factor on top. So then I'm going to look at the denominator and say, I bet there's an x plus 4 in the bottom. Just banking on it. Because I need factors of 12 that are going to add together to give me 7. 1 and 12 doesn't, 2 and 6 doesn't, but 3 and 4 do. And since they're both positive, that means the signs inside my factors will also both be positive. So I will have an x plus 4 and an x plus 3. But since I have that x plus 4 on top and the x plus 4 on bottom, they go away, leaving me with a 2 over x plus 3 as my final answer. If nothing had factored out of the top,
we don't have to.
You wouldn't have to factor the bottom in this case. And the only reason why I know that to be a fact, like let's do a little side thing. Let's pretend this had said 2x plus 5 on top instead of 2x plus 8. If nothing factored, that means this would be one of the factors of the bottom. But I know it can't be one of the factors of the bottom because of this 2x. Because then when I would multiply my first element of a factored binomial, I would have a 2x and an x, giving me a 2x squared, but that's not what we have down here. And so I can kind of use a little bit of logic to do a little less work in that case. But I will tell you, I did do most of the, actually I did all of the homework this morning, and almost always there's going to be something that factors out and cancels and something else. Because they're really wanting you to utilize all of that information that you learned in Chapter 6, again here in Chapter 7, and really master the factoring. I'll tell you, in college algebra, we spend, is it 1 day? I think we spend 1 day on rational functions. And it's a busy day. It's a whole 50-minute class, and I mean, it's just, we go. And this is one of the reasons why in this class we take so long mastering it so well, so that when you take college algebra, then when we're going 90 miles an hour through it, at least you've seen all of it and you can pick it up and you don't have to be completely lost. I could be wrong, but I feel like it's only 1 day that we spend on rational equations. Good question, though. Other questions? Because these are obviously the easier ones. Yes, this one has more work to do because we have to do the distributive property with our negative. We have to do factoring on both the top and the bottom and then cancel. But all of these first 4 problems already came with common denominators, and we didn't have to do anything. So are there questions before we have to go searching for those common denominators? Okay. Here's our last bit of notes. Least common denominator. The least common denominator is the smallest number that is divisible by both of the other denominators. Or when we go to solving our rational equations later on in this chapter, it'll be the least common denominator for all of the fractions or all of the denominators involved. And I'll show you a couple of different ways for finding these. If you're pretty good with your multiplication tables, then when it's just a numerical denominator, it's not too bad because you're just kind of doing multiplication tables to find that. But as we start adding in variables and things like that, then it gets a little bit more complicated. And I'll show you a couple different methods for trying to find these, depending on if we just have numbers in the denominators or if we have numbers and variables, or if we have quadratics and things like that. But regardless of how basic our denominator is or how complicated, our goal is always going to be to find that least common denominator. So we'll start off with just a numerical one just to kind of refresh our memories a little bit. Start off easy, get more complicated. So we have 1/3 plus 2/5. These do not have a common denominator. We have to find one. If you know what the smallest number is that 3 and 5 go into, then you're golden. If you're not sure, a good rule of thumb in order to find a common denominator is just to multiply your denominators together. And when we're dealing with just numbers, that's not too bad. But as we get more complicated and we have like a quadratic and a quadratic in our denominator and they're not the same, if you multiply those together, you're going to have an x to the 4th, and it gets really complicated really fast. And so that's a method you might want to use with numbers, but I definitely wouldn't recommend it for all of our problems as we move forward. So one of the easy ways of finding a least common denominator with numbers, and I know these are really easy numbers, but sometimes they're not, is you can take the largest number that's in your denominator, so 5, and write out some multiples. So take 5 times 1, 5 times 2, 5 times 3, 5 times 4, blah, blah, blah. And when you do this, after you write out a couple multiples, then ask yourself, does your other denominator go into any of these? And if so, then you're done. It doesn't go into 3, 10, but it does go into 15. So 15 is our least common denominator. In this case, it would be the same as if you just multiplied the two denominators together. And that's because both of our denominators are prime. So they don't share anything in common anyways. And so just multiplying them together is the easiest way to find your least common denominator. Now, once you've found your least common denominator, what you're going to do is you want to get both of your denominators to that number. And so you're going to look at each of your fractions and say, okay, I have 1/3 as my first fraction. What do I multiply 3 by to get to 15? 5. So you're going to multiply that fraction, top and bottom, by 5. That's key. Whatever you do to the bottom, you got to do to the top. Because here's what we're doing. What's 5 divided by 5? 1. So when you multiply by 1, did it change anything? No. In essence, what we did is we have this piece of pizza, and we need to subdivide it into smaller parts. We didn't change the amount of pizza we had. We're just changing the amount of slices that we have of that pizza. We're cutting them into smaller. So that's what we're doing whenever we're multiplying by this 1, which is 5 over 5. Then we're going to look at our second fraction, which is 2/5, and we need to multiply it by something to make 5 go to 15. So what do I multiply 5 by to get to 15? 3. And I got to do 3 on bottom, 3 on top. Because again, I'm just subdividing that piece of pizza. So 5 times 1 for this first fraction will give me 5. And then 5 times 3 gives me 15. Plus 2 times 3 gives me 6. 5 times 3 again gives me 15. And now we have a problem that looks just like our very first problem of the day. Same denominators, I can do the addition straight across the top, and I don't have to worry about it. One of the nice things is if you take the time to actually find the least common denominator, usually there's little to no simplifying on the back end. If you just find a common denominator, like if I would have said, okay, 30 goes with 3 and 5, I know that works, then I would have some simplifying here on the back end. Both ways would get you the same answers. Just always make sure that when you think you're done, you ask, does the top have anything in common with the bottom? And if you can confidently say no, then your answer is good. All right, let's do another one. A little bit more complicated. We'll throw in some variables this time. So we have a over x squared minus 3 over 5x. So this one's a little different. They're not just numbers on bottom. But I still need to find the least common denominator in this case. Oh, and that's actually all I was supposed to do on these problems. I wasn't actually supposed to keep going. So we're just going to find the least common denominator. You do have some problems in your homework where you're doing that and you're not actually simplifying the whole thing. So I guess be careful and read your instructions. I didn't read our instructions for this one. So for here, we would have just said the least common denominator is 15 and we would have been done. I made you do a little bit of extra work. So for here, I'm just going to find the least common denominator. And we're going to do it almost like a factor tree. I don't know if you guys remember when we did factor trees, but we had a number and then we'd factor them down until we got into primes, and we could do that as well with our variables. And so if I think about doing a factor tree, or if I think about factoring my denominator, I have an x squared. X squared is the same thing as x times x, and over here I have a 5x. I mean, I didn't really change anything. I'm just making it really apparent that that's 5 times x. And then I'm trying to find the smallest, basically, combination of these things where everything's included. And so here's what I mean. This denominator has a 5, but this one doesn't. So my least common denominator is going to have a 5. It's got to. Because that's the only number that's at play in our denominators. So now I've kind of dealt with that. This one has an x, but this one has 2 x's. And so in order to appease both of my denominators and find something that both x squared and 5x will go into, I'm going to have to go with the larger of the powers. So I'm going to have x squared to where I have 5x squared is the smallest thing that both x squared will go into and 5x will go into. This is a little weird because we're thinking about it in terms of x's and numbers. But I could multiply this first fraction by 5 and get this denominator. I could multiply this second fraction by x and get this denominator. And so it works. So you're looking for the number that would work for both of them. And luckily this one had a 1, so you didn't have to worry about it. And then you're looking for the variable. If they have the same variable, you're going to take the variable with the highest exponent. Let's do another one. We don't have to keep going with this one because we're just finding the LCDs. Which is good because this next one's a little bit more messy. Over 18x to the third y plus 5 20x squared y to the third. I'm going to take this off. Sorry, I'm moving stuff around. Hold on. Don't get seasick looking at this. All right, there we go. So we're not going to solve or simplify this at all. We're just finding the least common denominator. And our denominators here are a bit messy. We've got numbers involved, we've got x terms involved, and we have y terms involved. So let's look at our numbers first. We need to have the smallest number that both 18 and 27 go into. And so the easiest way to find that is to do a factor tree with those two numbers. Factor them down into their primes so that we can see what they have in common and what they don't. So remember, a factor tree, we go like this, and then we say what times what gives me 18. Well, I know 2 times 9 gives me 18. 2 is prime, so that branch dies off, and we don't have to worry about it. 9 is the same thing as 3 times 3, and there's my branches. I'm done. So 18 is the same thing as 2 times 3 times 3. Then I have x to the third y as my variables. I'm going to kind of ignore those first. I'm going to do my numbers. So now I'm going over to 27. What times what gives me 27? 9 times 3. And again, we already saw that 9 is 3 times 3. So what do these already share, number-wise? Yeah, they already share a 9. So really, I'm going to kind of cover up these bottom branches, and I'm going to pretend like our tree ends right here. because it actually makes our life a little bit easier. So if I'm looking at this, they share a 9. We used these factor trees to find the greatest common factor before, and now we're going to use them to help us find the least common denominator. So since they share that 9, I know I'm going to have a 9 included. But on top of that, I have to include the other numbers that I did not circle because they are not shared. So I include the 9 once because it's shared. And then I'm going to include the other factors. So 2 times 3 is 6. So I know I'm going to have a 54 something or other as part of my denominator. 2 times 3. The 2 that I didn't circle. Now, I said that with our variables, we're going to take the variable with the highest exponent. So if I'm looking at x to the third and I'm looking at x squared, when we're finding our least common denominator, we're going to have x to the what? Third, because we go with the bigger one, always. So you don't have to do any type of factoring. Just look and say, okay, I know I'm going to have an x term. What's my highest power? And you're going to go with it. Do the same thing for your y if you have another variable at play. I have y to the first and y to the third. So for my least common denominator, I'm going to have y to the what? Third. This 54x to the third, y to the third would be the least common denominator for these two different denominators. And luckily, in this section, you don't have to do anything with it. You don't have to make both of those denominators look like 54, x to the third, y to the third. You don't have to solve anything. We're not going to simplify. All these problems are going to ask for is find the least common denominator. So use factor trees for the numbers. You write down the shared numbers or the shared factors once, and you write down all the non-shared ones after that. So you will include all of them. Then you look for the variables with the highest power, and that's going to give you the rest of it. Now, once we actually start getting into binomials and trinomials, it actually gets a little bit easier, I think. It's a little bit easier to see what it is that your denominators already share, and you don't have to do the factor trees. So let's do one like that. Or are there any questions on this one before we move on? Let me see if you had any like this in your homework. This one's more complicated. 13 in your homework is a little bit similar to this one. But that's about as complicated as they get, I feel like. D will be 7 over 3x squared minus 6x. Plus, I'm going to write the denominator first because I like to center my top. So these denominators are obviously more complicated. I have a binomial in the first one, and I have this trinomial, this quadratic, in the second one. But we just spent a whole chapter learning how to factor these. And so when I'm trying to find the least common denominator between denominators like this, I'm going to factor them first. So what does 3x squared minus 6x, what do those two terms have in common that I can pull out? 3x. And if I factor out a 3x, it's going to leave me with an x minus 2. All I did was factor that bottom. That's it. So then I'm going to come over here, and I have an x squared minus 4x plus 4, and I want to factor this. So I'm going to have two binomials. My x squared tells me I'm going to have an x and an x. The positive sign in front of my c term tells me my signs are the same. The fact that it's negative here tells me they're both negative. So I need factors of 4, those are 1 and 4 or 2 and 2, that will add together to give me 4. Well, if I add 1 and 4 together, that gives me 5, so that won't work. So I'm going to have a negative 2 and a negative 2, like this. So once we've factored, it's almost like we did our factor tree. So what do our denominators share? Do they have anything in common already? They have an x minus 2. This one has an x minus 2, and this one has an x minus 2. So whatever they share, you write down once. So that's why I put like a little box underneath the ones that are being shared. I'm not going to write them a whole bunch of times. I'm just going to write those ones once. So the first thing I write is that x minus 2 that they share. Now, just like with our other one, though, up here, after I wrote down what they shared, then I had to write down everything they didn't share. So I do have to write down this 3x. And I do have to write down this other x minus 2 because the second term over here had 2 of those. The first one didn't. So I had to write down both. And before you think, oh my goodness, I'm going to have to multiply all this out, Pearson's actually really nice, and they say to leave it in the factored form. And so you are allowed to leave it as 3x times x minus 2 times x minus 2, or you can leave it as 3x times x minus 2 squared. Either of these answers are perfectly fine with Pearson. You don't have to distribute, you don't have to FOIL, you don't have to do all of that yuck. You get to leave it in the factored form because all we're trying to do is learn how to identify these least common denominators. So what they share, I wrote down once, and that's why I put boxes around them so I remembered I already dealt with these. And then anything else that's left over, you also will include in your least common denominator. Questions on this one? Okay. Let's do another. All right, where is that showing up for you? Okay, right there. I'm going to write the denominator first. X squared minus x minus 12. X squared minus 7x plus 12. And again, we're only trying to find the least common denominator. We don't have to simplify on this one. So you can really basically ignore the top. I'm just going to factor the bottoms to get started with so I can see if they already share anything in common. So for x squared minus x minus 12, I know I'm going to have two binomials. My first term will be x. Since the sign in front of my 12 is negative, I know that I'm going to have a plus and a minus. So I need factors of 12 that will subtract to give me just a 1. So factors of 12 will be 1 and 12, 2 and 6, 3 and 4. Which one of those sets will give me a 1 when I subtract? Which one? 3 and 4. Exactly right. Now, since my signs are different, I do have to pay attention where I put them. Since it's a negative x, I need to have more negatives than positives. So I'm going to put my 4 with the negative, and then I'm going to put the 3 with the positive. Again, you can always check your FOIL to make sure it works. And really, you're just concerned with the outer inner portion. For outer, you get negative 4. Inner, you get positive 3. That does add together to give you a negative 1. So this has now been factored. Over here, you're going to factor x squared minus 7x plus 12. Again, I will have an x and an x. The sign in front of my 12 on this right one, though, is positive, so the signs will be the same. And since it's negative in front of my 7, they will both be negative. So now I need factors of 12 that add together to give me 7. So again, 3 and 4, and luckily this time it doesn't matter because the signs are the same. So my denominator here was x plus 3 times x minus 4. Over here I have x minus 3 times x minus 4. Do my denominators share anything in common? Yeah, this x minus 4. They share this term and this term. So when I go to write my LCD, I know I have to have an x minus 4. After that, That's shared, so then I write down the two terms that weren't shared. The x plus 3 and the x minus 3. All of this would be the least common denominator. But again, we don't have to distribute, we don't have to FOIL, we don't have to do any kind of crazy math to actually figure out, that that's x to the third, blah, 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 blah. We get to leave it for now.
In Pearson, if we have a problem like that, can we write x minus 4 and then
The x squared minus 9?
Yeah.
I believe you would get counted wrong because it will be very specific and tell you to leave it in the factored form. And so this is the most factored form. But I would say test it. If you get one that does factor like this, test it in the homework and see if it tells you you're wrong or tells you you have the right answer, but you need to follow the instructions. Because like on the previous one, it would take quantity squared, and that was fine. But I think if you had the x squared minus 9, they would consider that not fully factored. And this is the only section, the 7.3 is the only section where we're just going to have some problems where it asks you to list the least common denominator. In 7.4, we will have to find the least common denominator, but then we're going to go ahead and simplify the whole problem. And so then it's going to change our answers a little bit to where we won't have them in the factored form by the end. Other questions on that one? All right, we got one more. Last one. You'll be grateful you did all this factoring and found the LCD, though, in this section. This is the denominator. I'm writing it first. Because then in our 7.4, we have to do all this, but then we're going to keep going with the problem itself. So we have 6w over w squared minus 4w plus 45 plus w plus 8. Now, all of our problems thus far, we've had a fraction plus or minus a fraction. This one's not written that way. So how would we make it a fraction plus a fraction? Yeah, we're going to stick this w plus 8 over 1. You can make anything into a fraction, any whole number into a fraction by sticking it over 1. You can make a binomial, a trinomial, any type of polynomial into a fraction by sticking it over 1. Most of the time we don't necessarily want to do that, but when we're dealing with rational expressions or equations and we're trying to get them together, then this is what we would do. Now, in terms of finding the least common denominator, it makes our life really easy. Because basically all we need to do is factor this, and we will have our least common denominator. Now, in a problem setting, like in 7.4, when we're actually going to be combining these, we wouldn't necessarily have to do the factoring because this denominator is going to be our least common denominator. But in 7.3, because it asks you to leave your least common denominator in factored form, we do have to go ahead and factor this w squared minus 14w plus 45. So we're going to factor it, and that's going to be our least common denominator. The w squared means I have w and w. The sign in front of my c is positive, so my signs are the same. Since the sign in front of my b is negative, they're both going to be negatives. So I need factors of 45 that add together to give me 14. Well, 1 and 45, 5 and 9, 3 and 15. I don't know if there's any others. So which of those pairings would add together to give me 14? 5 and 9, and since the signs are both negative, it doesn't matter which one I stick where. Since the denominator over here is a 1, whatever your denominator is in your first fraction, that's your least common denominator. You don't have to find anything else. It's just going to be W minus 5, W minus 9. But I like to throw that one in at the end just because it does look a little bit different than the other problems because it started with a whole number or a whole expression that we then stick over 1. And you do still have to factor, but that's just because of the way the problems are worded.